Hey! Hey! I'm Mr. O, here with another moment at the Children's Museum of Houston. Let me pose a question to you. On this end of the string, I have 14 washers. On this end, only one washer. So what do you think will happen if I let go of the string? So hopefully you knew that the 14 washers would produce more force due to gravity and pull the single washer up and over my finger. But let's change one thing. Same string, same number of washers on each side, but in this case, what if instead of holding the string straight up and down, I hold it out to the side before letting go? Will it behave any differently? So, by holding it out, instead of the heavier side pulling the lighter side over my finger, the lighter side wraps around my finger, stopping the heavier side from falling. So, before we talk about why this happens, I think it's important for you to try it yourself. Let's wrap our heads around this. We're going to make a wrapping toy. For this, you'll need 15 washers. They don't need to be this big though, and string. First, cut off about a 24-inch length of string. If you need to, tie a knot in either end to keep it from unraveling. Tie a single washer to one end of the string. Tie all the other washers to the other end. Holding onto the single washer, hang the bundle of washers over a stick or even just your finger or a friend's finger. Finally, hold the string off to one side and let go. The key for the string to wrap around my finger is that the washer needs to build up enough momentum in order to overcome the force of gravity pulling it down. Momentum is a measurement of the amount of motion an object has. It's the product of multiplying the mass of the object, or how much matter is in it, and velocity, or how fast it's going in a given direction. As the washer swings down, right here at the bottom is where it has maximum momentum. As it swings back up, gravity starts pulling down, causing it to slow down. If it doesn't have enough momentum at this point, it won't swing back up and wrap around your finger. But if it does have enough momentum, it wraps around no problem. So how does the washer build up enough momentum to wrap around my finger? Well, we're going to break it down to two parts, the swing and the pull. When I talk about swing, I mean the single washer acts in part like a pendulum. A pendulum is basically a weight attached to a string that swings around a fixed point, and pendulums have some unique properties related to their swings. When any object is dropped, gravity causes it to accelerate. The farther it falls, the faster it goes. But with a pendulum, the distance it can fall is controlled. A short string means it doesn't have far to fall. The longer the string gets, the farther it can fall and the faster it will be going when it reaches the bottom, and therefore will have more momentum. But that's only part of it. There's another piece to this, the falling of the weighted end creating pull on the opposite end. That pull does two things. It adds more momentum and it shortens the string. In physics, we think of force and motion having direction, that direction being known as vectors. The pulling down of this end due to gravity means this end is pulled, but not straight up. It's being pulled at a diagonal. In other words, it's being pulled both vertically and horizontally. So some of the force pulling on it moves the washer up, and some of it pulls it into the swing, adding more velocity and therefore more momentum. So as I pointed out earlier, the falling of the weight shortens this string. But why is that important? Well, we need to go back and take a look at our pendulum. As we already discussed, when a pendulum swings, it generates momentum, which is at its maximum at the bottom. That momentum then carries it against the pull of gravity back up to almost the same height on the opposite side. But what happens if we shorten the string during the swing? See, it swings higher. The original momentum was for a longer string. With a shorter string, that same momentum will carry it higher. Pulling it all together, the swinging down of the single washer builds momentum, and the pulling up of the washer adds to the momentum. And as the weight pulls down, the string gets shorter, so there's less distance to travel. The momentum of the washer is more than enough to overcome the force of gravity pulling down on the washer as it swings back up, allowing it to swing up and over my finger. Once it reaches the top, the momentum starts to build up again because of gravity pulling down until it reaches the bottom. Once again, the momentum is more than enough to carry the washer back up and around on a shorter string due to the string wrapping around my finger. This continues until the string is totally wrapped around my finger. So while this is obviously a fun little toy to explore, what relevance does it have? Well, number one, obviously it demonstrates some important physics principles, but it also is a great foundation for science projects like science fair. Remember, any good science experiment is a controlled experiment, meaning you only change one variable, and this toy has a lot of variables to explore. One variable is how you hold the string. Does the angle of the string affect how well it works? Is there a minimum and maximum angle for this weight? Another is the weighted end. Do you really need 14 washers? Will fewer washers work? Or is there such a thing as too many on one end? For that matter, what about the washers? Would the same system work for something with less mass like paper clips? And if it does work with paper clips, can you reduce the 14 paper clip weight as far as you were able to reduce the washer weight? And of course, there's the length of the string. What if you make it shorter or longer? And once you do that, can you go back and get it to work at the same angles that you did with the 2-foot string? And there's what it's wrapping around. Would it work as well around a pipe as it would a chopstick? And of course, there's the string itself. Would it work as well with nylon line or thread? And well, you get the idea. There's a lot of very complex variables to explore with this simple little toy. This has been another Oh Wow moment from the Children's Museum of Houston. We hope your mind can come out to play.